Particles A and B are attached to ends of light inextensible string which passes over a smooth pulley. The system is held at rest with string taut and its straight paths vertical. Okay, let me highlight this that initially the U is going to be 0. Both particles are at a height of 0.36 meters above the floor. The system is released and A begins to fall, reaching the floor zero point 0.6 seconds later. Okay, so this is going downwards, and this time here would be 0.6. This is going to be S, and U is going to be 0. Okay, find the acceleration of A as it falls, so we can use S is equals to UT plus half AT squared. 0.36 equals 0t plus half a t square. Solve this and this should give you the value of a. This gives a equals 2 meters per second square. Okay. So a comes out to be 2. Find the mass of A is 0.45 kgs. Find the tension in the string while A is falling. Okay. Now, since the mass, let me just clear this. Okay. The mass is 0.45, so the weight is going to be 4.5. Tension is going to be backwards in this direction. And for B, it's going to be here, and its mass is going to be here. So that's going to be 10 m, and this is tension. Anyway, back to A, we need to find the tension in the string while A is falling. So we're going to use Newton's second law of forward force, which is 4.5 Newton's weight, minus backward force, which is the tension, is equals to mass, which is 0.45, into acceleration, which is 2. This should give the value of T, 3.6 newtons. The mass of B, okay, so for B is going to move upwards. We're going to do forward force, which is T, minus backward force, which is 10 m, is equals to mass times acceleration. Acceleration of both the particles stay the same. So that's going to be 2. Okay. Also, we found tension, which is 3.6. So 3.6 is equals to, this will be 12 m. So 3.6 upon 12 should be equals to m, which is going to be 0.3. Okay. Next is the maximum height above the floor reached by B. Okay. So when A will hit the ground, when A will cover a distance of 0.36, B will cover a distance of 0.36 in the upward direction. So the total height above the floor so far is 0.36 plus 0.36. But as this A hits the ground, the string slacks and this particle further rises up in height till its final speed becomes 0. And since the string is taut in this, sorry, is not taut, that is, it is slack, here acceleration is going to be the free fall upwards acceleration, which is minus 10. Okay. Now, the speed here of the block is going to be the same as the speed of A as it hits the ground, which was, do we have this value? No, we do not have the value of this V from this part, but we can always find it out because uh, we have S, we have A, we have T, we have U. We need to find V, so I'm going to use V is equals to U plus AT here. V is equals to U plus AT. V is what we're trying to find. U was 0, A is 2, and time was 0.6. So V comes out to be 1.2. So this is going to be the V here of A right before it hits the ground, and the V of B here right before slacking takes place. So V is 0 point, what did we just get? 1.6. V came out to be 1.2, sorry. Okay. So this is the V for this part of the journey. But now this is going to be U for this part of the journey. So we're going to call it U moving forward. Okay. So now we know that between this part, U is 1.2, V is 0, gravitational acceleration is -10. We have to find the distance covered. V square equals U square plus 2AS. 0 square is equals to 1.2 square plus 2 minus 10S. This gives the value of S 0.072. Okay, now the total distance is 0.36 plus 0.36 plus 0.072, which gives 0.792. That's the maximum height above the floor reached by B.